In case 4, the denominator is going to have a repeated irreducible quadratic factor. All right, so we know what a quadratic factor looks like. It's going to have the form ax squared plus bx plus c, and it is going to be repeated, meaning it's going to appear in the factorization more than once. In doing so, it might just be raised to a power. So if it's squared, for example, that means it's being multiplied by itself. Or if it's cubed, that means it's being multiplied by itself 3 times. So that's how you're going to see it be repeated. Okay, so this is what we're going to do to handle a repeated irreducible quadratic factor. Remember, it's irreducible, can't be factored further. It says, suppose the complete factorization of q of x, which is again our denominator, it contains the factor ax squared plus bx plus c raised to the k power. So that k powers is indicating that we have a repeated factor. It's multiplied by itself k many times. Okay, the ax squared plus bx plus c can't be factored further, meaning it's irreducible. So to handle such a partial fraction decomposition of p of x over q of x, you're going to do this. Okay, so you're going to take the factor. The factor itself is ax squared plus bx plus c. So this is going to produce k many fractions. So if you notice, the denominator is always some power of ax squared plus bx plus c. It will start with the first power of ax squared plus bx plus c, meaning this is raised to the first power. And then in the second fraction, this quantity will be squared. And then you will keep doing that until you get to the kth power. Okay, so you'll have the third power, the fourth power, all the way up to the kth power. Okay, as far as the numerators are concerned, remember the denominator is a second degree polynomial, so each of the numerators need to be of first degree. So they're going to have the format lmx plus b. Okay, again, if you have a irreducible quadratic factor that's repeated, if that's in your denominator, you can still have other things in your denominator. You can have another quadratic factor that's not repeated. You can have one that is repeated. You can have a linear factor that's repeated or not repeated. So this is how you would handle just the quadratic irreducible factor. Okay, that's repeated. Okay, so let's try out example 4. We're going to find the partial fraction decomposition for the given rational expression. This time we have x to the 4th plus 3x cubed plus 4x squared plus 2x plus 4. All of that is over x times x squared plus 2, which is squared. Okay, so this one looks a little complicated, especially because that numerator is so long. Okay, let's talk about degrees here. The numerator is going to be degree 4. The bottom is x times the x squared plus 2 is squared. So this is really x squared plus 2 times itself. Okay, that's how this can break down. Notice that inside the parentheses, the x squared plus 2, you cannot factor that any further, okay? So if you were to multiply this out, you can just multiply out the x pieces to figure out the degree. This would be x times x squared times x squared. And so if you add the exponents here, this tells you that we're dealing with a degree 5 polynomial in the bottom. So since the degree of the numerator is less than the degree of the denominator, this is going to be just one of the cases. Okay, it'll be case 1, case 2, case 3, or case 4. Okay, so we need to figure out which case we're dealing with. Okay, I am going to go ahead and write this whole thing out. So this long numerator, and then here's the bottom. Okay, the bottom, I'm going to go ahead and write it this way. Well, I'll just write it as it comes. Okay, so when we look at this denominator, okay, like I said, we have two distinct factors, you have the x squared plus 2, which is repeated because you see it twice in the factorization, and then you have this x, okay? So when you look at the x, this is a linear factor, and it's not repeated, okay? It's x to the first power. You only see it once in the factorization. On the other hand, this x squared plus 2, it is repeated and it's quadratic. Okay, if you look inside of the parentheses, the highest power of x is 2, and you see this thing twice in the factorization. Okay, so we're going to have to handle each factor in the denominator separately. We are going to start with the linear factor that's not repeated. Okay, since it's not repeated, we're just going to have a single fraction. It will be over x. And this is degree 1. So in the numerator, we need to go down a degree to degree 0, which is just a number. Okay, that's it for the blue x. Now we're going to move on to the x squared plus 2, those yellow guys. Okay, so these are repeated factors. It's repeated 2 times. So it's going to produce 2 different fractions. The denominator of the first fraction is going to be the factor raised to the first power. So essentially, this is just going to be x squared plus 2 like this, okay? Because if it's raised to the first power, you don't need to actually write that, okay? The other denominator, okay, because it's repeated twice, is going to be that factor, that quadratic factor, but now you need to square it, okay? So that's what the denominators are going to look like, okay? And then as far as the numerators, remember your factor, if you're looking inside of the parentheses, the factor itself is quadratic. So that means the numerator needs to go down a degree. What's in the numerator needs to be degree 1. Okay, so it's going to have the format mx plus b. So we've already used an a. So on this next term, it's going to be bx plus c. Okay, and then on this other piece, it's going to be dx plus e. Okay, so there's 5 constants that you're going to have to solve for here. Okay, so we did think this was definitely more complicated. You can see that it really is. Okay, this is the setup. Okay, this is the hard part, and now we're going to have to solve for the a, the b, the c, the d, and the e. Okay, so to do this, we need to go ahead and eliminate the fractions. Okay, so what I will do here is, I guess, I'll write it again. Okay, so give me a second. Let me jot this down. All right, so here is the first fraction, and I'm going to write it out so that this bottom is factored. It's x times x squared plus 2 times itself. It might be a little clearer here if I do that, okay? And then I'm going to try to separate these guys out. We have a lot going on here, so it's going to be kind of hard to spread it out, but I will try. Okay, so let's do this. And then give myself some room. Dx plus e over this quantity. Okay, lots going on here. Okay, so we're going to try to get rid of the fractions. Okay, so let's do this. If we go to the fraction on the left side of the equation, okay, this has the entire denominator. So we're going to go ahead and multiply this fraction by the entire denominator. X times x squared plus 2 times x squared plus 2. Okay, then that red quantity will cancel with the denominator here because they're the same. If I multiply the left side by this red quantity, I have to do it to all the other parts. So a over x is going to have to be multiplied by it, as is the bx plus c part. As is the dx plus e. It's a lot. Okay, the more you write out, the less likely you are to make a mistake. Okay, let's clean it up and eliminate the fractions. On the left side of the equation, we have x times x squared plus 2 times x squared plus 2 in the top and in the bottom, they're going to cancel and leave you only with the complicated numerator. Okay, on the right side of the equal sign, we will start with the a piece. Okay, we see that we have an x in the bottom. It will cancel with this x right here. So we're going to be left with a times the quantity x squared plus 2 times x squared plus 2. Then we have a plus sign. And then for this bx plus c part, we have an x squared plus 2. In the bottom, it cancels with one of these. So this is going to turn into the entire quantity bx plus c times x squared plus 2. Okay, that's what that turns into. And actually, just so I can multiply it out easier when it comes to that, I'm going to switch the order of the x and the bx plus c. Okay. All right, and then we're going to have plus, okay, in the bottom here, x squared plus 2 squared is x squared plus 2 times itself, so this cancels with this and this, and so this last piece is going to turn into x times the quantity dx plus e, okay? Make sure you're using good parentheses, okay? Fractions are gone, but unfortunately we have a lot to multiply out, okay? I'm not going to keep writing the left side. Okay, I'm just going to work on the right-hand side. I'll leave the left side alone. Okay, so I'm going to leave the a out front, and then I'm going to multiply out the x squared plus 2 times itself. This is going to give us x to the 4th plus 2x squared plus another 2x squared plus 4. All of that is multiplied by a, okay? Then I'm going to leave the x out front, and I'm going to multiply the bx plus c times x squared plus 2. This is going to give me b times x cubed plus b, 2b times x. The inner terms will give me c times x squared. The last terms will give me 2 times c. And then luckily, the dx plus e part is not so bad. Okay, so we'll go ahead and distribute the x here and here. So we're going to have plus dx squared plus ex. Okay. All right, now we're going to send the a through everything in parentheses. So we're going to get ax to the 4th plus 2ax squared. Actually, let me back up. Okay, let me combine these guys in, let's combine these like terms. The 2x squared plus 2x squared will be 4x squared. Okay, and then I'll go ahead and send the a through. Okay, so this is going to be ax to the 4th plus 4a times x squared plus 4a, and then I'm going to send the x through. That's going to give me plus bx to the 4th plus 2bx squared plus c times x cubed plus 2 times c times x. And then we have the dx squared and the ex. Okay, so very complicated. You've got to be very careful not to make a mistake here. All right, remember, this is all equal to x to the 4th plus 3x cubed plus 4x squared plus 2x plus 4. Okay, at this point, you can combine like terms. I'm just going to do it as I equate coefficients, I guess. Well, I'll do it this way. Let me write the left-hand side one more time. Just trying to make sure this is clear to you. All right, so plus 2x plus 4. Okay, when I scanned the right side, the highest power of x is 4. So I'm going to start by combining everything that has an x to the 4th. So that's this guy and this guy. Okay, so if I have a many x to the 4th and then I have b many of them, I have a total of a plus b many x to the fourths. Okay, so the x to the fourth pieces are taken care of. Okay, so now I'm going to go to the third power. So I'm going to look for anything that has x to the third power, and I only have one thing. Okay, so this is going to tell me, I'm just going to add c times x cubed. Now I'm going to look at everything that has an x squared. Okay, so we have 4a many of them, 2b many of them, and d many of them. So if you just add the numbers in front, this is going to be 4a plus 2b plus d many x squareds. Then we're going to look at just the first powers. So we have this guy, this is x to the first power, this is x to the first power. So we have 2c many x's and then e many x's. So that's going to be a total of 2c plus e many x's. And then I'm looking for anything that is just a constant. Okay, well, the only thing left is 4a. So that's going to be the constant here. Okay, and now we equate. Okay, I need to equate the numbers on both sides of the equation in front of the x to the fourths, the numbers on both sides of the equations in front of the x cubes, and so on. Okay, that's going to give me a system of equations. Okay, I'm obviously out of room, so I'm going to do this on the next page. Okay, when I look at this, the number in front of x to the fourth, okay, there's 1 on the left. This is really 1 times x to the fourth. That has to equal a plus b. So I'm going to start writing this on the next page. So a plus b has to be equal to 1. That's the first equation that we get. And then let's compare the numbers in front of x cubed. 3 has to be the same thing as c. Okay, so that's really nice. Okay, so we're going to say that c has to equal 3. So that's actually one of the coefficients already. Okay, and then if we go back, we compare the stuff in front of x squared. So we have a positive 4 over here, and then we have this business. So we have to write that 4a plus 2b plus d has to equal 4 if you compare the stuff in green. And then we keep going, compare the stuff in front of just an x. Okay, 2 has to equal 2c plus e. So 2 has to equal 2c plus e. And then we have one more. Okay, so the constants have to equal. So let me get another color here. We are told this time that 4 has to equal 4a. If we compare those guys, those are just the constants. Okay, so going back over here, we know that 4a has to equal 4. Okay, so we have 5 equations in 5 variables. So this looks like a daunting task, but it isn't so bad because we already know the c value. C has to be 3, and the a value is actually easy to calculate. Okay, if you come down to the last equation here, all you have to do is, well, let me just use a different color here. All you have to do is divide off the 4. Okay, so if I have 4a is equal to 4, divide by 4, this is going to tell me that the a value is 1. Okay, so we already have 2 of the numbers that we need. Okay, so it's not so bad. Okay, now that we know that a is 1, okay, we can come up here, mark straight up here. We know a plus b has to add to 1. So if we have a plus b is equal to 1, we know that a is 1, so replace that. And then solve for b. Okay, we're going to get that b has to be 0. Okay, so there's your third constant. Okay, all right, so let's work on the stuff that's remaining. We still need d and e. Okay, so actually we can solve for either one first. If we look at this particular equation, we know both a and b, so we're going to be able to get d. Okay, I know that 4a plus 2b plus d has to be 4. Okay, I know that a is 1, so this is going to be 4 times 1 plus 2 times b. B is 0 plus d has to be 4. So this tells me that 4 plus 0, this part will go away. So 4 plus d has to be 4. Okay, you can solve this for d by subtracting the 4 off. You're going to get that d is also 0. Okay, so we've got some stuff disappearing here. And then now I just need e. Okay, then we can go write down the partial fraction decomposition. Okay, so let's go right here. Okay, so let me keep this color coded so you can keep this straight. So from the equation in blue, I know that 2c plus e equals 2. I know what c is. C is 3. So this tells me 2 times 3 plus e equals 2. 6 plus e equals 2. Subtract off the 6. I'm going to get that e is equal to negative 4. Okay, I've got all my coefficients. Okay, so I am going to be able to go back and write my partial fraction decomposition now. Okay, all right. So what I'm going to do here, okay, I need to go back to the original fraction. I'm going to move this. Let me rewrite this somewhere else. So this is repeated quadratic. All right, remember, I had already formed the recipe here for figuring out this partial fraction decomposition. Okay, so let me see here. Let me highlight this recipe. This is what we're following. Okay, we know A, B, C, D, and E. Okay, let me go and write those down. All right, so we know D is 0, E is negative 4. So we know D is 0, E is negative 4. Okay, and then we also know that A is 1, B is 0. Okay, so A is 1, B is 0. And lastly, we know that C is 3. Okay, so we should be able to write down our partial fraction decomposition. Our original fraction is going to be equal to a over x, that's 1 over x, plus the b is 0 here. So the bx is going to go away because b is 0. Okay, we still have the plus c in the top, so this is going to be 3 over x squared plus 2. And then we still have the plus. The d is equal to 0, so the dx will go away. We still have the plus e, so that's going to be minus 4, okay, over x squared plus 2 squared. Okay, this is the partial fraction decomposition. You can change the plus or minus into just subtraction, but this is the final answer. Okay, that very complicated initial single fraction, you can write it as the sum or difference of these 3 fractions. You can check yourself by getting a common denominator and combining these 3 fractions into one and multiplying out or simplifying or factoring, whatever you have to do to make sure you get what you started with. We are done.